Bismillahirrahmanirrahim. In this session, we will discuss radioactive decay. Radioactive decay is the emission of alpha. As a result of the radioactive decay, alpha, beta, and gamma radiations emits. So the alpha particles or beta particles from an unstable nucleus. So alpha or beta decays, the nucleus changes to that of a different element, which may itself be unstable. So the nucleus or the atom changes to the other element, and that element is still radioactive, so it further decays until it gets stable elements. So it produces series of decays. So once it started radioactive decay, and after so many decays, stable elements are formed. So these changes are spontaneous and random and cannot be controlled. So this radioactive phenomena, this kind of decay, is a spontaneous and random phenomena, and it cannot be controlled. But it does not matter whether the material is pure or combined chemically with something else. So alpha decay, alpha is a helium nucleus. So helium atom, so it's a nucleus, helium nucleus. Alpha particle is also known as helium nucleus, having 2 protons and 2 electrons. Helium has a 2 proton and 2 neutrons, and when an atom decays by emission of an alpha particles, so if any atoms that decays by emission of an alpha particle, its nucleon number decreases by 4. So its nucleon number decreases by 4 and its proton number by 2. If an element is undergoes an alpha particle emission, so it means that alpha particles is emitting from that element. So as a result of that, the nucleon number will decrease, as is happening in a radium nucleon. So this is radium, which is 88 and 26. So this 88 reduced to 86, and this 226 reduced to 222. So this is radium, and this is a new elements form, and this Rn is also radioactive, and this alpha particles. So this is a simple example of radioactive decay, where the radium is transformed to radon and alpha particle. This helium is basically alpha particle. Helium nucleus is, this is helium nucleus. The value of A and Z must balance on both sides of the equation, since nucleons and charge are conserved. So this 86 plus 2 is 88, and this 222 and 4 is 226. The beta decay, the beta or a negative decay, a neutron changes to a proton. So this neutron changes to a proton plus electron. The proton remains in the nucleus, and the electron is emitted as a beta negative particles. The proton remains in the nucleus, and the electron is emitted as a beta negative particle. The nucleus, the new nucleus, has the same nucleon numbers, but its proton numbers is decreases. So in a beta reaction, this is carbon 14, a radioactive element. It emits beta. So as a result of this beta emission, so this carbon 14 transforms to neutron. Nitrogen, this is with a proton number is 7, and mass number or nucleon number is 14. So this is no mass, so this nucleon is 0, and the charge is negative. So this has a negative charge. So this is beta decay. A beta decay is often just referred to as beta negative decay, is referred to as a beta decay, simple beta decay. In a beta decay, neutron turns into a proton and an electron, so that the number of neutrons in the nucleus decreases. So the number of neutrons decreases because this transforms to a proton. This increase in the stability of nucleus that has an excess of neutron. So this increases the stability of the nucleus that has an excess of electron. The factors affecting the stability of nuclei are considered in more detail. Opposite the gamma emission, after emitting alpha particles and beta particles, some nuclei are left in an excited state. After emission of alpha and beta particles, gamma emits. It's usually happens. So rearrangement of the proton and neutron occurs and a burst of gamma emission is released. So here are some. Now put this into practice. This is from the book. Americium decays by emission of an alpha particle to an isotope of neptunium. So neptunium, write down the decay equation. So this is americium and this is neptunium, and helium is released. So this neptunium number is from 95 to 93 and this 241 to 237. So this is the simple reaction of alpha decay. Yttrium 3991 decays by an emission of beta particle to an isotopes of zirconium. Write down the equation. So this is 39 yttrium. So this 39 becomes 40 and this 491 is 91 still. This is yttrium to zirconium and this is beta decay. In the next session we will discuss this.